All right, now we're going to take what we went over in the last video, and we're going to apply it to an actual problem. All right, and so we are now going to complete the square on this one. Now, you may look at this, right, and you'll say, well, what's the matter with this? Why can't I use this? Well, the problem is you can't really factor this how it is. It doesn't factor nicely. Okay, negative 11, two factors of negative 11 that add up to 10. Honestly, I can't really find them, right? I don't know what they're going to be. So, the only two factors I know of 11 are 11 and 1, and if it's negative 11, that means, so if that's the case, right? So what we're going to do is when you can't find them, right, because I was kind of lying, I can't find them, but I'm not going to tell you that. What we can do is we can show you that this is, you can achieve what you want to do through factoring by completing the square. So let's go over how we do this. All right. So the first thing we're going to do is we are going to rewrite this equation, and I'm going to take this and I'm going to move it over to the other side. Okay, so when I do that, I'm basically adding 11 to both sides, right? I'm adding 11 to both sides. I'm not going to go through every little single step with this, because hopefully at this point you can just kind of grab it and flip it over to the other side and just make it positive, right? So this is what we have. All right, so now what I'm going to do is I'm going to complete the square. So I'm going to, first of all, I'm going to take my b term, all right? My b term is 10, and I'm going to divide it by 2, all right? And that's going to give me 5. Now the next thing I'm going to do is I'm going to take this and I'm going to square it. So you take that and you square it, which gives me 5 times 5, which is 25. And then the last step is I am going to add this to my equation. All right. Now the difference here, okay, is when I add this to my equation, because I have a balanced equation here, right? I have x plus 10x plus 25 equals 11. So think about this for a second. Let's say we're on a teeter-totter, right? And here's your teeter-totter, and I've got x squared plus 10x just chilling over here, right? And we've got 11 chilling over here. And then I say, okay, guess what I'm going to do? I'm going to take 25, right? And I'm going to just drop it on here with this. Well, the thing is, that's going to throw this out of balance. So in order to keep it in balance, I have to put another 25 over on the other side to keep it in balance. Okay, so I added it here, so that means I need to add it here. Okay, and that's just the basic principle of algebra, is that whatever you do to one side, you do to the other. So I thought the visual might be kind of helpful for that, right? So now I know that this is a perfect square trinomial, so I can write it as a perfect square trinomial and write it as x plus, and it's always the square root of this, right? And then your sign is always going to be dependent upon what b is. If b is positive, your sign's positive. If b is negative, your sign's negative. So I have x plus 5 squared equals 36. Cool. All right. So now we're going to do what we've been doing the past couple days, and you guys are probably already sick of it or have forgotten it. And we're going to take the square root of this. So this is going to give us x plus 5 equals plus and minus 6. So my solutions are going to be x plus 5 equals positive 6, or x plus 5 equals negative 6, right? I subtract 5, and I get x equals 1. I subtract 5, and I get x equals negative 11. Okay? And those are my two solutions. I got those from completing the square. Now, remember when I said before that I couldn't solve this, like the factoring wouldn't work? Well, I was misleading you, all right? It actually does work. If you take this and you multiply using our AC method, so you have a negative 11 times 1 equals negative 11. Two factors of negative 11 that add up to 10 are 11 and negative 1, right? And so when I put those in, I will I will get something that looks like x plus 11, x minus 1, right, equals 0. And then when I solve that, I have x plus 11 equals 0, which means x is negative 11. And I have x minus 1 equals 0, which means x is equal to 1, right, which are the solutions we got to. So when you can factor, you're probably going to want to factor because it is a lot faster than completing the square. But completing the square, if you don't think you can factor, is probably your best bet, right? It's a really direct route, and it works pretty well. All right, so we'll pause the video there, and then we'll have a couple more examples for you.